In this video, we'll discuss European mathematics from 500 to 1600. Now, to begin this time period, from 500 to 1000 is considered the Dark Ages of Europe, when much of the continent is run by feudal estates that don't work together and don't share much knowledge or marketing. Therefore, there's little trade and little need for the advancement of mathematics of this time frame. What mathematics and science that was being learned was being done at monasteries, often run by Irish monks, who helped to slowly establish schools across the continent. One of their biggest issues at the time was trying to determine when to put Easter on the Christian calendar, and they had to use different forms of mathematics to connect both the Roman solar and Jewish lunar calendar. This mathematics then became part of the mathematics taught in the monasteries. Now, as we get to the turn of the millennia, we have Pope Sylvester II, who took time to go to Spain and learn from the Islamic scholars. And he took that knowledge that he learned about mathematics and started to bring that back to the schools in Western Europe, including the use of the Hindu-Arabic numerals without the number 0. Now, when we look at how did knowledge transmit through this time period, we think at that time the Arab nation was at some of the height of its strength, which meant that Baghdad was the center of much of the knowledge. The works of both the Greeks and the ancient Indians were brought to the Baghdad Library for translation. That knowledge was both translated and then expanded, so that meant that Spain and Africa also gained that knowledge as they were part of the Arab nation. We have a little country of Sicily that spreads in Europe and becomes a connection point both for trade and for some of the Crusades as it goes on. And then through the Crusades and through trade, slowly Western Europe begins to gain some of this new knowledge as well, and then allows them for their advancements. So we can thank, unfortunately, the use of the Crusades for bringing some of that knowledge back to Europe. As they would conquer parts of Spain, the scholars would come in and translate the Arabic works into Spanish and from Spanish into Latin. Once it was in Latin, it could then be transmitted across Europe. Some of those scholars included Adelard of Bath, who translated both works of Euclid's Elements and Al-Khwarizmi's Astronomical Tables from Arabic. Also, one of the most influential translators of the time was Gerard of Cremona, who did over 80 different works from Arabic, including Ptolemy, Aristotle, Archimedes, Euclid, Al-Khwarizmi, and a second translation of the Elements. And these works are what helped to slowly spread knowledge and advancement in Western Europe. Now, one of the famous early mathematicians of the early Middle Ages was Fibonacci. He was the son of a merchant, so that allowed him to travel. And during the travels with his father, he learned Arabic and then mathematics from Muslim teachers in northern Africa. He used that knowledge to bring back to Europe as well and wrote the Liber Abaki, which it was influenced by both Al-Khwarizmi and Abu Kamil. That included the Hindu-Arabic numerals, which helped to slowly spread them around Europe. And it included much of early arithmetic and elementary algebra. This represented some of the greatest comprehensive works of Islamic mathematics being brought to Europe. But we have to remember, if he's using Al-Khwarizmi and Abu Kamil, he's over 200 years behind where the Islamic nation was in their understanding of mathematics and science. He did write other works in geometry, trigonometry, and indeterminate analysis. Now, some other notable mathematicians of the 1200s and 1300s include Jordanes of Nemours, who was a contemporary of Fibonacci. His work helped to focus on the use of proofs and verifications when doing mathematics. It displayed a form of Pascal's triangle hundreds of years before Pascal gets his credit. Additionally, it integrated much of the works that come from the Greeks and the Arab scholars of that time. Now, when we look at 1300, we're seeing that this is the Black Plague and the 100 Years' War. So the growth is slower during this time frame, much because of what's going on around. But we do have different mathematicians that do help influence and improve the mathematical situation of Europe, including Nicole Oresme, who was the first person that has published work showing the use of a basic coordinate plane. He also worked with fractional exponents and was considered the predecessor to infinitesimal analysis. Now, as we get into 1300s to 1600s, we're looking at the Renaissance period, and this is where we start to see significant growth in mathematics and science in Western Europe. This is helped by the printing press being invented, which then allowed for easier dissemination of knowledge across the continent. Due to trade and navigation and the establishment of different types of things like universities, the knowledge then becomes more widespread, and then that helps to continue to build upon where we've been at that time. So we see the mathematics slowly improve over hundreds of years throughout Western Europe, so that by the end of this time frame, the mathematical understanding of Western Europe is parallel to what's going on in the Islamic world, in India, and in China, and other major civilizations around the world. This is when we see widespread translations of the classical works across the whole known world at that time. And due to the Renaissance and the use of syncopated algebra, we see the creation of the symbolic algebra as that becomes more and more prevalent in the 1500s. Now, other mathematicians that helped spur some of this advancement include Johann Euler, who translated much of the classical works from the Greeks, including the Alchemist. Now, because of his translation of the Almagest, he recognized that there was a need for a prerequisite to help other scholars learn. So he created a plane and spherical trigonometry work that was independent of astronomy, which was the first time that this occurred within Europe. Another important mathematician of the time was Nicolas Choquet, whose tripartite advanced many of the works he worked with irrational and irrational numbers, as well as positive and negative exponents, something that was very unique for that time frame in Western Europe. He also started to utilize syncopated algebra. So we're starting to move into syncopated algebra in the 1400s, which then allowed for the construction of symbolic algebra by the 1500s. The same was true for Luca Pacioli, whose Summa compiled all of what was considered known mathematics and algebra, geometry, and arithmetic of that time, and that was able to then be spread across Europe. Again, his use of syncopated algebra helped to then set up for the use of symbolic algebra in the 1500s. Now, when we think about what helped create improvements in algebra in the Renaissance, first we have the use of the Hindu-Arabic numerals being spread across Europe. It was hesitant at the beginning, but then as the ease of using them to help do the calculations became more prevalent, people took and used them more commonly. We also see the syncopated algebra slowly transition into using symbols that, again, helped with the simplification of sharing of knowledge as well as doing different calculations. We see things like the plus and the minus get used more commonly, an equal sign, or radicals, the use of brackets and braces, and then actually with Francois Viete, creating a text, a treatise that actually goes through and helps to understand how should we look at the structure of equations. All of these things slowly build to what we think of as our symbolic algebra. Now, as we get into the 1500s, we have other important mathematicians that helped with, as we think about the progressing of mathematics. For example, Cardano was born in Italy and was one that fought hard to finally be able to study medicine. But some of his works that are helpful were the Ars Magna, or the Great Art, which was the first Latin work that focused only on algebra in Europe. It included things like negative roots, computations of imaginary numbers, complex numbers that had not been seen in Western Europe prior to this time. Also, near the end of his life, he was known to be a gambler, and he created a gambler's guide. And if we look through those works, we see concepts of probability that show up several, 100 years later. Now, one of the most notable mathematicians of the time was Francois Viete, who was a French mathematician that worked for King Henry III and IV. And he was one that was able to do a lot of cryptography and decipher Spanish code during their war with Spain, so that this greatly helped the French as they were in their war. His greatest work in Artem developed the foundations of what we think of for symbolic algebra. One of his key things that we think of is the idea that he used vowels for unknown quantities and consonants for known quantities. So we see the use of letters in replacement of numbers. Additionally, he actually started to use the same letter with multiple powers to represent quantities, whereas prior to that, different letters were used for different quantity powers. He also simplified written operations, but did not use the equal sign. His work was also significantly influential within trigonometry, such that we think about the trigonometric functions and their equations. That comes from the works of Francois Viete. Now, some other famous mathematicians of the 1500s include Clavius, who was a very gifted teacher that created multiple textbooks both in arithmetic and algebra that then spread across Europe. We have Simon Stevin, who introduced both the theory of decimal fractions and had other contributions in science, including hydrostatics and military engineering. For example, he's known for creating a chariot that would use sails near the ocean that could then carry up to 30 men into battle. And then we have major advancements in science through people like Nicolas Copernicus, who was credited for the heliocentric model of the universe, which likely was based on some works from others prior to him. But his model at that time in Western Europe then required significant advancements in what we think of with trigonometry. And it also changed how we think about Earth in comparison to the heavens above. Now, Jorge Joachim Redis was a disciple of Copernicus, and then he took those works and started to define the trigonometric functions as ratios of the sides of a right triangle, which was the first that had been done, especially in Western Europe. And here we see the mathematics of the Renaissance is starting to spread and enhance where we go forward.